Okay, so solve the system by substitution, right? So what you're going to do here is you're going to solve for a variable, and you're going to plug it into the other two equations. So if we pick the first equation, we have x plus y plus z equals 10, and we can solve for z, okay? Or rather, let's solve for x instead. So if we solve for x, so to solve for x, you do minus y and then minus z on both sides, right? So this gives you x equals 10 minus y minus z, right? So this turns into x equals 10 minus y minus z. Let this be new equation 1, okay? Now what you're going to do is you're going to plug this into the two other equations for x. So you have 2x minus 7y plus 8z equals 47. So then you're going to plug in what we got for x. So you have 2 times the quantity, 10 minus y minus z, and then minus 7y plus 8z equals 47, right? So then you do distributive property. 20 minus 2y minus 2z minus 7y plus 8z equals 47. Now you subtract 20 on both sides or you can combine like terms and then subtract, right? So then you have negative 2y minus 2z, minus 7y, excuse me, plus 8z equals, and then 47 minus 20 is 27. So then you combine like terms, you have negative 9y plus 6z equals 27. Let this be new equation 2. So this is the new equation that we came up with, was negative 9y. So now we have negative 9y plus 6z equals 27. So now do the same thing for the other equation. So you have x minus 2y minus 5z equals negative 29. So doing so, we have 10 minus y minus z, and then minus 2y minus 5z equals negative 29. So then this gives us 10, and then negative y minus 2y, that's negative 3y, and then negative z minus 5z is negative 6z, is equal to negative 29. So now go ahead and subtract 10 on both sides, and you have negative 3y minus 6z equals negative 39. Let this be new equation 3. So basically turns into this. Hold on. Basically it turns into this. Negative 3y minus 6z equals negative 29, or negative 39, excuse me. So now solve this new linear system. You have negative 9y plus 6z equals 27, and negative 3y minus 6z equals negative 39. Since this is substitution, we have to solve one of our variables for one of our variables in one of the equations. So if we grab if we have negative 9y plus 6z equals 27, we can solve for z by adding 9y to both sides. So then this gives us 6z equals 9y plus 27. If we factor out a 3 on both sides, we get 3 times the quantity 3y plus 3, or I'm sorry, plus 9. So then this gives us, and if we divide it out, this gives us 2z equals 3y plus 9. Now to solve for z, we just have to divide by 2 on both sides, since we have nothing left to factor out. This gives us z equals 3y over 2 plus 9 over 2. So then we can plug this in for the other equation. So basically, this gives us, so we have z equals 3y plus 9 all over 2, right? And that's the equation we came up with. So now we're going to have to plug that in to the second one. So negative 3y minus 6z equals negative 39. We're going to plug this in for z. So we have negative 3y minus 6 times the quantity 3y plus 9 all over 2, right? Equals negative 39. So now you have negative 3y minus 18y over 2 minus 54 over 2 equals negative 39. So now this gives us negative 3y minus 9y, and then 54 over 2, if I look it up really quick, is 27. So minus 27 equals negative 39. This gives us negative 12y minus 27 equals negative 39. Now to solve for y, all you have to do is add 27 to both sides, excuse me. So adding 27 to both sides, we get negative 12y, and then is equal to negative 12, right? So this, we divide by negative 12 on both sides, we get y equals 1. To solve for z, all you have to do is use this equation. So we know that y equals 1, so z is equal to 3 times 1. Sorry, hold on. 3 times 1 plus 9 all over 2. This gives us z equals 3 plus 9 all over 2, which is equal to 12 over 2, which is equal to 6. So z equals 6. And now to solve for x, we have y equals 1 and z equals 6. So now, and we had x equals 10 minus y minus z. So y equals 1 and z equals 6. So basically, we have x equals 10 minus 1 minus 6. This gives us x equals 10 minus 1 minus 6, which is x equals 9 minus 6, which is x equals 3. So these are your 3 solutions to the system, or your 3 coordinate points. Now, as an ordered triple, your answer should be in terms of x, y, z. So it should be 3. So x equals 3, y equals 1. So 3, 1, and then z equals 6. So 6. So this is your final answer for this problem.